second sheet, you're going to do the second page, and the second page involves full proofs. Okay, so this will be our first attempt at geometric proofs. Okay, they're all going to be based on this segment addition postulate. So all you're really going to use in your proofs is segment addition postulate and then the different axioms to manipulate it. Okay, so I want to go through an example of what it will look like as well as the strategy I'd suggest you use when approaching these types of proofs. Okay, so the first thing, it'll give you a picture and a set of given statements. Okay, and it'll give you an end state that you're looking to reach. Okay, so again, you should always be able to start off very simply by copying down what was given. Okay, so when I look at this, it says AB and DE are equal. Okay, and now what I want to do is I want to build this proof in order to end with the statement AD is equal to BE. Okay, my suggestion for how to approach these, and it's real systematic. Okay, start by interpreting the given information. Okay, so if the given information is a statement like C is the midpoint or B is the midpoint or whatever, then you can interpret that and say that therefore these two segments are equal. Okay. In this case, the given statement is just a relationship of segments, so there's no way to interpret that. It's already been interpreted for you, so you move to the next step. So the next step after interpreting the first given statement, my suggestion is introduce the elements of your end state. Okay, so here my end state has to have an AD and a BE. Do I have either of those yet? No. So I'm going to introduce AD. And when you introduce it, here's my two suggestions on that. Introduce it in the exact form that it asks you for. So isolate AD, get it completely by itself. And then introduce it in terms of whatever else is already introduced in the proof. So here I look at AD. Okay, so when I look at AD, how is AD built from what's already given AB? AD is a whole piece, so it's equal to a part. Since the only other part in this is given is AB, I'm going to use that. And then what's the remaining part after AB? BD. So you'll use that. Okay, don't put BC and CD. Okay, just do all that remains. So the BD remained. Okay, and what justifies that statement? I used segment addition. Okay, so I've introduced my element AD. So the next thing I want to do is introduce my next element, BE. So I can do that in the same step. BE is this whole segment or distance. And if I, again, kind of build it in the same way, in terms of what's already there, I have DE, and then what remains to make that whole part EB, also BD, right? Now, I don't need to, I can create this as step 3, but since it's justified with the exact same reason, I can just continue it as a second line on step 2, which is what I'm going to do. Right, so I've introduced my two end state elements. Once you have those introduced, all parts of your end state introduced, then you start to work backwards and figure out what do I need to do in order to get these statements or end states completely by themselves. Well, looking here, in order for AD and BE to be equal, I need to make sure that either AB plus BD is equal to DE plus BD, or I need to transform one of these statements into the form of the other. And I'm going to show you both of those methods. Okay, so one method is if I can show that AB plus BD is equal to DE plus BD, then I'm able to prove that these two things would then be equal. So let's see if that's possible. What if I go back, in order to show that AB plus BD is equal to DE plus BD, I need to start with my given statement that AB is equal to DE. So all I've done so far here is I've just rewritten statement 1. But in order to transform statement 1 into AB plus BD, what do I need to do to the left side of it? I need to add BD. And to balance the equation, what do I need to do to the other side? Add BD or its equivalent. In this case, I'm going to add BD to both sides. And what do you call it when equals are added to equals, the wholes are equal? That's referred to as addition property. Okay, so we can justify that statement as being addition property. And now once I get this statement, what can I replace AB plus BD with? What is that equivalent to? It's equivalent to AD. And what can I replace DE plus BD with? It's equivalent to BE. And so by looking at this, we can think of this as one of two ways. We can say two things, or in this case, if we are replacing AD here and replacing BE here, replacing something is referred to as substitution. Okay. Right, so we would call that or define that as substitution. So this is, we've reached our end state. AD is equal to BE. So we're done with our proof. It took us those 4 steps to do that. Okay, so that's one way to approach this proof. And I want to go through a second way. Okay, as I mentioned, when you're dealing with proofs, oftentimes what happens is there's more than just one way to complete a proof. So let me go through an alternate form of this. Right, we'd still need to begin by introducing the elements, so my step 2 is still going to stay exactly as it was. But let's say instead of creating a form, if I didn't see that AB and B, or this statement AB plus BD and this statement could be set equal, the other alternative is to take one of these statements and see if we can transform it into the form of the other statement. So let's say I take this bottom one, BE is equal to DE plus BD. What if I rewrite that, but instead of DE, what is DE equivalent to? AB. So I could say BE is equal to AB plus BD, and all I did there was I replaced DE with its equivalent AB. So what was that called? Replacing is called substitution. And now notice this isn't an example of transitive property. So we're not saying two things are equal to the same thing. All we're doing is saying one thing can be replaced by another. So that's substitution. And now once I get to this statement, what you should be able to see is we have two things, AD and BE, that are set equal to the same thing, AB plus BD. So two things that are equal to the same thing are what? Equal to each other. So AD and BE are equal to each other. And the process of that, what axiom is that? Things which equal the same thing are equal to each other is transitive property. Okay, now transitive property can always also be called substitution. Okay? But the other way around is not true. So step 3, we saw an example of substitution that's not transitive property. But step 4 is an example of transitive property. Well, we could have just taken statement 2 and written AD, but we could have replaced AB plus BD with its equivalent BE. So you could think of that as substitution. You can also think of it as transitive property.